we have to start a new chapter, optics. In optics, we have to learn about light, ray of light, beam of light. So, what is light? First, we have to discuss about light. So, what is light? In electromagnetic waves, we have already discussed the light, that is a non-mechanical form of energy. Non-mechanical energy. Light is the form of energy which is non-mechanical. Non-mechanical means it does not require any medium for its propagation. Does not require any medium to travel. In a medium, light can travel, but also it can travel in vacuum. Clear? The source of light is sun. And here the earth surface. You are here. And in between the distance from sun to the observer, a lot of space is vacuum. And the sun ray, that it can travel in vacuum and reach to earth surface, from which we can say the light that can also travel in vacuum. No medium is required for its propagation. And remember, in vacuum, the speed of light is, in vacuum, speed of light is 3 into 10 to the power 8 meter per second. Light can travel with this much speed. Clear? That's why we can say light, that is a non-mechanical energy. Clear? And the light ray that travel in a straight line. Suppose here, this is one ray of light. Ray of light, and when more than one ray, suppose 2 or 3 rays come, here we can say there is a combination of ray of light, and combinedly we can say beam of light. Clear? When one ray that travels, we say that this is a ray of light, and when more than one ray comes, we can say a bundle of ray of light or beam of light. Clear? So in our optics, it is divided into 3 types. One is geometrical optics which is also known as ray optics. The next is wave optics. And next one is number 3, quantum optics. So in your syllabus, we have to discuss only the geometrical optics and wave optics. In geometrical optics, that is also known as ray optics. That means here we assume the ray of light that travels in a straight line. Clear? So next, we have to discuss about ray optics. In ray optics, there are different phenomena of light. Geometrical optics. First one is reflection of light. Here you have to assume first rectilinear propagation of light. Rectilinear propagation of light. That means we have to assume here light can travel in a straight line. Number 2, reflection of light. Next is refraction of light. And next assumption is we have to assume, no, it is compulsory, no two rays depends upon each other, they travel independently. So next, so first we have to discuss about reflection of light. We will discuss reflection of light. So in reflection of light, we require one reflecting surface. Reflection of light. Let xy is the reflecting surface and this is the medium air, and let this is the normal. Normal means perpendicular. This is the normal to the surface ON. And in reflection of light, let a ray of light AO, the ray of light which incident to the reflecting surface is known as incident ray. And in reflection of light, here the ray of light which comes, or the incident light that changes direction without changing the medium. That means this medium is air and there is no medium below, only the reflecting surface and the medium is air, and the ray of light AO that fall on the surface, reflecting surface, and change its direction and move in this way, OB. Clear? And here we say AO, that is the incident ray, as it is incident on the reflecting surface. So AO is the incident ray, and the angle made by the incident ray with the normal, that is known as the angle of incidence. So what is angle of incidence? Angle of incidence is that angle made by the incident ray with the normal. And again there is another angle, that is the angle made by the reflected ray OB with the normal, and that is the angle of reflection. So reflection of light is a phenomenon in which the ray of light changes its path without changing the medium. Then there are two laws of reflection. The first law is, here incident ray is there, normal is there, and reflected ray is there, and the reflecting surface is there. So we have to take all the things in first law of reflection. That is, we can say the incident ray and the reflected ray and the normal to the reflecting surface at the point of incidence all lies in a same plane. That means if you take, this is a plane, this is X, this is Y plane. If you take, so we can say the incident ray, the reflected ray and the normal to the reflecting surface at the point of incidence all lies in a same plane. This is first law of reflection. And in second law of reflection, there is a angle of incidence, and another angle is angle of reflection. So in second law of reflection, we can say the angle of incidence will be equals to the angle of reflection. That is, angle of incidence is equals to angle of reflection. This is the second law of reflection. Clear? And next